Okay, so what I want to do today is talk about translating really square root graphs. So what we're really trying to do is f of x equals either the square root of x, or we're going to do f of x equals a cube root of x. So we're going to translate both of those, all right? But before we do that, I'm going to go back to a plain old x squared, which has a very similar shape. We go back through what we already know, then we'll turn the page and we'll take a look at them as square roots or cube roots, okay? So radical functions. It's either a square root of x or a cube root of x, but let's start first with our plain old x squared. So we've done this before. We know if we take 0, 0 squared is 0. So we put a dot at 0, 0. We go 1. 1 squared is 1, so we got a point at 1, 1. We plug in 2. 2 squared is 4. 1, 2, 3, 4. 3 squared is 9, so go 1, 2, 3, and 1, 2, 3, 4, 5, 6, 7, 8, 9, okay? Now, it's a parabola, so it really does have a negative half, okay? So it has a point on negative 1, 1, negative 2, 4, and negative 3, 9, okay? So a parabola actually has a negative half because we can square negative numbers, okay? When we get to the other side, we won't do the negatives because we can't do the negative parts of a square root. We'll only see this part. Now the vertex in this case is 0, 0. Okay? Domain, that's easy. Domain, even though it's going up forever, it's always moving over. It's always moving over. So the x values are everything. So as far as domain, it's x equals all real numbers. But the range is different. It starts at a height of 0 and goes up. It does not exist below. So it's just at 0 up. So the range is just y is greater than or equal to 0. We've done these before. We've done parabolas. They're not too bad. Now, in example 2, we're going to take our parabola and we're going to move it. We're just going to translate it. So it's always going to be the opposite of the inside. Opposite. So instead of going back 3, we actually go to the right 3. So our vertex is at a positive 3, positive 2. So we take the opposite of the inside. It's the value that zeroes it out. So we go to 3, 2. And then we just take our parabola and make a translation from 0, 0 to 3, 2. So we'll do the same thing. We'll do our, from the vertex, 1, 1, 2, 1, 2, 3, 4, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. It has a line of symmetry down the middle. Same thing, we've got a 1, 1, 2, 4, and 3, 9, and then there is our parabola. Now again, domain and range. Parabola domain's always going to be all real numbers because you can plug in any x value, not only that, but it's always moving over on both directions. Even though it looks like it's going up, it's constantly moving over, okay? One.
Do you always have to draw the line?
No, you don't need the line of symmetry. No, I draw it just so you can see that it's a flip, right? Yeah. So domain's easy. X equals all real numbers. But range is different because range, it starts at a height of 2 and goes up from 2, all right? There's nothing below 2. So we're going to state y is greater than or equal to 2. Example 3. Let's take our function, let's take our parabola, and let's move it to negative 1, 4. Okay, so our vertex is going to be at negative 1, 4. But this one is going to be upside down. Okay, so we're going to take it, we're going to flip it. This one's upside down. So from my vertex, I'm just going to do my 1, 1, 2, 2. I'm sorry, 1, 1, 2, 4, 3, 9, but I'm going to do it upside down because of the negative, so we'll still do our 1, 1, 2, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. The same thing on the other side. The graph in our parabola. Okay. Domains, all real numbers. Always will be. Always will be all real numbers. Thank you, Taylor. Because it goes forever wide, even though it looks like it's not going to, it's always moving over in both directions. So the domain, plus you can plug any value you want in here. So the domain really is x equals all real numbers. In this case, the range starts at a height of 4 and goes down. So the y value of the range is going to be y is less than or equal to 4. Range, domain. Now, we did those so that when we flip the page, we're going to be doing square root graphs. We're going to be doing the same way, except for one thing. The other half of the parabola won't be there. We just have the half of the parabola because it's the opposite. It's an inverse function. So okay. So ready? Okay, Grace, I'm going to turn it in a second. Give me a thumbs up, Grace. It's okay, get it done.
Mr. Davies,
Mm-hmm.
was Friday's notes, did you record them?
Yeah.
Oh.
And you got it? Okay, the other side. Now, the only difference is we want to use a square graph. So the normal, let's look at the parent. This y equals square graph. Let's go ahead and graph what we call the parent function. So the parent function is the main, it's the main graph. The main graph, and then we'll move it, okay? So the main graph, its endpoint is at 0, 0, 0. I'll go 1, 1 because the square root of 1 is 1. But then I'll go over to 4. I need to go over to 4 because 1, 2, 3, 4. Because I know what the square root of 4 is. Square root of 4 is 2. I could do all the numbers in between, you know, square root of 2. I could do the square root of 3. But there's no reason to. Same thing of 5, 6, 7, 8, 9. I'll go all the way to 9 because there is a square root of 9. A nice square root of 9. A whole number, which is 3. Now, I don't go back here. I'm not going to do negatives, okay? You can't do the square root of a negative number. So this part of the graph back here does not exist. So the square root graph really is this part right here. And there's no graph underneath either. That is it. That because we can't do negative square roots. So that's our parent function. The domain, well, it starts at 0 and goes forward. There's nothing back here. So the domain is just x has to be greater than or equal to 0. Okay? And the range, it starts at a height of 0 and moves up. So the range is just y is greater than or equal to 0. Okay? There's my domain and my range. So what I want to do now is take that square root graph and move it. I'm going to do a translation. So to do a translation, first of all, let's figure out what the endpoint is. It's not really a vertex. It's more like an endpoint. So the endpoint is the opposite of this, which is 3, 2. So we'll find 3, 2, and that's my endpoint. Now we'll take our square root graph and just start it there. So we'll translate this exact picture and put it right there, okay? That's all we have to do. We're just going to move it. So we'll still do our 1, 1, 4, right? 4, because the square root of 4 is 2. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3. And we don't need all the numbers in between because they're just decimal numbers anyway, right? We need the general shape. We just connect the dots.
Wait, what is the endpoint I need?
The endpoint came from right there. And it's the opposite of that number. And then that. Yeah, endpoint, starting point. How's that? Becca? Well, same thing. How's that? Starting point's a great way to put it, okay? Call it the starting point instead of an endpoint, okay? Now, domain. What's the domain? We start at 3. A value of x is 3 and move over. So it's just going to be x is greater than or equal to 3. That's my domain. And the range, we start at a height of 2 and go up. So it's just y is greater than or equal to 2. Okay? All right. Cube roots. Same type of translation, but a totally different look. The graph looks different. We looked at it already. It looks like this. This is my cube root. But we're going to put it back up there again, okay? So let's just first of all do the cube root of x right here. So the cube root of x, let's think about this, okay? What times what times what, okay? What times what times what? Cube root. What times what times what? So the cube root of 0 is 0. Cube root of 1 is 1 because 1 times 1 times 1 is 1. Now the next good number or whole number that we can cube root is 8 because 2 times 2 times 2 is 8. So I go all the way to 8. 1, 2, 3, 4, 5, 6, 7, 8. So I'm using these numbers. I'm using 0, 1, and 8 because those have cube roots. Perfect cube roots. Now I'm also going to use negative 1, negative, and negative 8. 0 of course, but negative 1. The cube root of negative 1 is a negative 1. 1, 2, 3, 4, 5, 6, 7, 8. Cube root of negative 8 is negative 2. So the shape looks like this. It has a little bend right there in the middle, okay? That's our inflection point. That little middle point is our inflection point. So when we move this, when we do a translation, I'm going to keep in mind that this is the point I want to move. I want to move this inflection point back, forth, up, and down. Right, Garrett? Back, forth, up, and down, right? So let's see. Let's take, and let's move our inflection point to a negative 1, negative 3, okay? For this example right here, we're going to move it to negative 1, negative 3, okay? Goes right there. So we take this shape and we just put it here. Take this shape, put it right there, okay? So the same shape, we're going to go, 1, 1, we'll go 8, 1, 2, 3, 4, 5, 6, 7, 8, 2, because the cube root of 8 is 2. We'll have negatives. We can have negatives. We'll go back 1, down 1. Now we're going to go back 8 to get a decent number. I'll go back 1, 2, 3, 4, 5, 6, 7, 8, and down 2. Okay, and here's my graph. Domain and range. I like the domain and range on this stuff. They are both all real numbers. It goes forever back and forth. And it is always moving up, just slowly, and it is always moving down, just slowly and gradually, okay? This graph is always moving up. This graph is always moving down, okay? Because you can take cube roots of bigger and bigger and bigger numbers. You just get the cube root of those numbers, okay? All right, last but not least. So again, this is our parent function. This is our parent function. What we want to do with this is our inflection point is going to be at negative 3, 2. So let's find that. Negative 3, 2, all right? Now, the negatives on the inside. When the negative's on the outside, we flip it over the x. When the negative's on the inside, we flip it over the y. So we're going to take our shape and we're going to flip over the y-axis. So what happens is this shape right here, we just flip it over. We're just going to flip it over the y. So we're going to turn it that way. See how it works? We're going to turn it this way. So we're going to take it and we're going to turn it this way. Okay. So we'll do our 1, 1, but it goes up like that. Our 1, 2, 3, 4, 5, 6, 7, 8, 2. Put it there. We'll do our 1, 1 here. And our 1, 2, 3, 4, 5, 6, 7, 8, 2 there. And so here is our shape. Here's our cube root graph, which has been moved and flipped over the y-axis. Okay? How's that?
Are we done?
We are